So it's saying uh, solve the equation for the rate of growth if the rate of increase is proportional to the number present. So that just means dn over dt proportional to the number present. So let's just call it kn. But the population is being reduced. So after it's being born, it's being reduced at a constant rate by the removal of bacteria for experimental purposes.
Yeah.
So what I think we should do this part first, separately,
Yeah.
by separation of variables, and then we can take into consideration the change. So here, if you separate the variables, you get dn equals kn dt, and if we divide both sides by n, and so let's start, go ahead and start working on this part here first, and then let's see what we, this should be straightforward. So 1 over n dn is equals to k dt, and now we can bring in the integrals. K is a constant, it can come outside the integral, and then we will get the integral of 1 over n is ln n equals kt plus c. Uh, and then let's say we start with n at 0 equal to n0. It doesn't specify, so let's just say n of 0 equal n0. Whatever n0 is doesn't matter. Just to find c, so finding c, and so if we plug in, we get ln n0 equals c. So c equals ln 0, plug it back in, we get ln n uh, ln n equals kt plus ln n0. Bring ln 0 to the left, so we will get ln minus ln n0 equals kt. Properties of ln's, we can put ln over n0 equals kt, exponentiate, and n over n0 is equal to e to the kt. Multiply n0 on the right hand side, and we get n equals e to the kt. So this is the number of bacteria at time t. Okay, now we need to, so did you get to this point so far?
Yes, yeah, I got that.
Okay, now it says the population is reduced at a constant rate by the removal of bacteria. Okay, so let's say that the removal rate is r. Whatever r is, doesn't matter.
Right.
Removal rate is r, and this is just bacteria per, if we're working here with per unit time, whatever the unit time is. So it's being removed at a certain number of bacteria per unit time, where of course r has to be, you can't remove more than what you have. So the rate has to be between 0 and 1.
Right.
And less than 1. Because at 1, it's what you have. 0 is nothing.
Yeah.
You're not removing anything. So then how much do you have remaining? So number of bacteria, the number of bacteria remaining at time t will equal to how much you produced, which we found to be n0 e to the kt, minus how much you remove. And how much do you remove? Well, you'd have to integrate the rate between t and t plus dt to tell you how much you remove bacteria per unit time for that time. So you can actually integrate 0 to t, the rate of removal, right?
Yeah.
That's bacteria per unit time, times the number of bacteria present, because this is just the density state of the bacteria that you have available. So the rate of removal,
Yeah.
right,
Yeah.
times e to the kt dt. So that's bacteria per unit time times the time would get you the number of bacteria multiplied by the exponential that you have it at any time t from 0 to t would tell you how much you are removing. And so now this becomes n0 e to the kt minus r is a constant. E to the kt becomes e to the kt divided by k, chain rule backwards, from 0 to t. From 0 to t. From 0 to t, I'm talking right hand side here. Only this. So this becomes n0 e to the kt minus r. If you plug in, so if you call this the dummy variable of integration t prime, just so that it's different, so this becomes t prime. So plug in t for t prime, you get, so let's take this k outside. So you would get e to the kt minus e to the 0 is 1. E to the 0 is 1.
Yeah.
So n of t would equal this. Uh, so notice at t equals 0, e to the kt is 0. So you get 1 equal 1. So you get 0 times r over k would get you 0. So at t equals 0, you just have n0. And from there on, as time increases, you would remove e to the kt minus 1 times the rate of removal divided by the rate of production.
Right.
Um, so this would be the differential equation governing the scenario where you have the rate is proportional to the number of bacteria present and the rate, and it's being removed at a constant rate.
Right.
Questions on that question? You could scroll through this.